Hey everybody, this video is for anybody who missed today's Zoom session. We're just going to go over the notes real fast, okay? So, oops, sorry, cat in the way. This is going to be going over these notes that we did earlier today in the Zoom session, okay? So, basically, the question is that in 2016, 9% of juniors passed the SBAT. In 2017, 16% of juniors passed the SBAT. Compute a 95% confidence interval for the difference. So we're going to do it two ways. One is by hand, and the other is using a calculator, okay? So the first way is by hand. So what we're going to do is we're going to just determine which sample should be sample 1 and which sample should be sample 2. It doesn't really matter which order you do it in, but you just want to pick one. So I picked 2016 to be sample 1. Therefore, for P1, Q1, and N1, I'm going to use the data from 2016. For 2017, I use the sample 2, so I'll use that data to get P hat 2, Q hat 2, and N2. So basically, I'm calculating this standard deviation here. Don't forget the 9% is 0.09, not 0.9. And then you got to find Q hat by doing 1 minus that, and it's over N. Then you're going to do the same thing with the second sample. So again, P hat is the percentage. You plug that in. That's 16% times 0.84 divided by 361. Once you plug all that in your calculator, just make sure that when you do it that you're not putting any parentheses, because if you put parentheses, it's going to mess up the PEMDAS. So what you should do right now is pause this video and check if you get this when you plug everything in. So go ahead, try that, make sure you're getting it. Okay, so now we're going to plug everything into the confidence interval formula. So we're subtracting the two p hat values, and then you're going to get z star out of the chart, which is 1.96 for 95%. And then we're going to use the standard deviation here. So just subtract these, you're going to get this, and then multiply those. Obviously, I got this. And then when I did plus or minus, I was able to get this right here. Okay, notice how both of my interval values are negative. So what that means is that I actually, it really implies that whoever went first, whoever your first sample was, which was 2016, they did worse because their values are coming out negative. So if the values came out positive, that would mean the people in 2016 did better, because the group that you're putting first is the one that you're thinking of first. Okay, so when we interpret it, the interpretation, I actually highlighted this for you guys. So it always starts with, we are 95% confident that. Okay, then if you notice the blue right here, this blue represents the first sample. So my first sample were the juniors of 2016. So I said, we are 95% confident that the juniors from 2016, so that's your first sample, scored between 2 and 12%. Well, where am I getting those? Obviously, I'm getting them from my interval. So I just rounded this up to be 12. So between 2% and between 2% and 12%, I use the word lower. Why? Well, the reason I use the word lower is because both of my interval values were negative, which means that these people did worse than these people. And then finally, the last thing, the purple, is just me plugging in the other sample, which was the juniors. I wrote 2018. It should say 2017. It's a typo. Okay, so now we need to go over just one thing from the calculator portion. So you guys, have you ever heard that commercial that says 4 out of 5 dentists prefer dentine? Okay, so that's 4 out of 5 dentists prefer dentine. So what that means is that 4 out of 5 dentists prefer dentine. If you put that in a calculator, you would get 0.8. 0.8 would be the p hat for that problem. 4 would be the x value, and 5 would be the n value. So the point is that your calculator is going to ask you for the x value, which is the number of people who did something. In this case, it would be the number of people who passed the SBAC. Whereas you don't need that information for this formula, but you will when you're plugging it into the calculator. So the way that you can calculate what X is if you don't have it is, you could use algebra. So if you plugged everything in, like I did here for this example, I plugged in p hat of 0.09, I plugged in n of 348. All you need to do is multiply both sides by 348, right? And that would give you the answer. So if I multiply both sides by 348, that would give me X. So that's why I multiplied those two together. For all of your X values, you have to round to the nearest whole number. The reason why is because your calculator won't let you input it if you put in a decimal. The other reason why is because you can't have half a junior passing the SBAC. That doesn't make any sense. So just make sure you round to the nearest whole number. If you're off by 1, it shouldn't really affect your results that much. So I did the same thing with X2. So I multiplied p hat times p hat 2 times n2, and that gave me the X2 value. Then you're going to plug it into your calculator. Okay, here's the part where I'm going to have to actually stop this video and make a separate video on how to do it in the calculator, because you guys aren't going to be able to see the screen because it's so small. So I'm going to stop there, and in my second video, you're going to see how to input everything into the calculator in order to get the answer. Okay, thanks for watching.